Mathematical induction part 4.
Hello everyone. In this session we will discuss 7 marks questions. This is the continuation of previous class. ఒకవేళ మీకు ఆ ప్రీవియస్ క్లాస్ ప్లేలిస్ట్ కావాలంటే లింక్ డిస్క్రిప్షన్ లో ఇచ్చాను చూడండి. సో వితౌట్ డిలే కమింగ్ టు టాపిక్, షో దట్ 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on n terms, which is equals to what? N into n plus 1 whole square into n plus 2 by 12. Now see the given statement: 1 square plus 1 square plus 2 square plus and so on. Clearly, what is the nth term here? 1 square plus 2 square plus up to so on n square. So that is what? Sum of the squares of the n terms formula. So we know that sum of the squares of the n terms, n into n plus 1 into 2n plus 1 divided by 6. So which is equals to n into n plus 1 whole square into n plus 2 divided by 12. So clearly which is LHS and which is RHS. So this is equation 1. So first case 1. In case 1 you prove for given statement is true for n is equals to 1. So you can consider LHS as well as RHS separately. So here n is equals to 1. N is equals to 1 means consider only first term. So that is what LHS is 1 square. We know that 1 square value 1. So next consider RHS. So what is RHS? This one. That is n into n plus 1 whole square into n plus 2 divided by 12. Here we can substitute n value is 1. That is what? 1 into 1 plus 1 whole square into 1 plus 2 divided by 12. So clearly which is what? 1 into 1 plus 1 whole square, that is 2 square is 4 and 1 plus 2 that is 3 divided by 12. So 4 into 3 12, 12 by 12 1. Clearly LHS and RHS are equal. We can say that the given statement is true for n is equals to 1. So next case 2, assume that n is equals to k. So means you can replace n by k in equation 1. So write LHS is equals to RHS. So that is 1 square plus 1 square plus 2 square and so on. Here replace n by what? K in LHS as well as RHS. That is k into n plus 1, that is k plus 1 into 2n plus 1, that is 2k plus 1 divided by 6. On RHS also you can replace n by k, that is k into k plus 1 whole square into k plus 2 divided by 12. So which is equation 2. Now in case 3, you prove for n is equals to k plus 1. You can consider LHS, from that you can prove RHS. So clearly what is LHS? LHS of equation on this one. That is 1 square plus 1 square plus 2 square and so on plus replace n by what? K plus 1. And also you should mention the bracket for k plus 1. That is k plus 1. Next, n is what? K plus 1 plus 1. Next, 2n plus 1. That is 2 into what? K plus 1 plus 1. So which is divided by what? 6. Clearly, which is what? Sum of the k plus 1 terms. So sum of the k plus 1 terms write as sum of the k terms plus k plus 1th term. So which means already we have sum of k terms value this one plus k plus 1th term. That means RHS of case 2 plus this last term. Okay. Clear what is the RHS of case 2? This one. So that is k into k plus 1 whole square into k plus 2 divided by 12 plus last term. What is the last term? This one. K plus 1, k plus 1 plus 1. That is k plus 2 multiplying with 2. 2k, 2 into 1, 2 plus 1, that is 3, which is divided by what? 6. So clearly once you observe here, which terms are common? See here, k plus 1, k plus 2, k plus 1, k plus 2. And this is what? 6 multiple. 6 also common. So clearly here, k plus 1 into k plus 2, which is divided by 6, is common. What are the remaining terms in the first? K in the numerator. Again one more k plus 1, which is divided by 6 2's plus 2. Again k plus 1, k plus 2 by 6 is common. Here we have only 2k plus 3. So clearly this can be written as k plus 1, k plus 2 divided by what? 6. And what is the LCM here? 2 is the LCM. Cross multiplication. K into k plus 1 into 1. Again k into k plus 1. K into k square plus k into 1, k. Next, cross multiplication. Multiply with 2. 2 into 2k, 4k. 2 into 3, 6. That is 4k plus 6. Again, which is k plus 1, k plus 2 divided by 6 into 2. 12 into k square, k plus 4k. That is 5k plus 6. Again, which is k plus 1, k plus 2 into. See here you can do the factorization because of this is the quadratic expression. See here clearly 1 into 6, 6. Multiply any two numbers, product is 6 and sum is what? 5. So clearly what will you get? One is k plus 3 and another one is k plus 2. So we can write as k plus 2 into k plus 3. So because of 2 plus 3, 5. 2 into 3, 6. Okay. Which is divided by what? 12. Again, which is k plus 1. K plus 2 into k plus 2. K plus 2 whole square. Into k plus 3. Which is divided by 12. Again, this is k plus 1. How to write k plus 2? K plus 1 plus 1. K plus 1 plus 1 whole square. And how to write k plus 3? K plus 1 plus 2. K plus 1 plus 2 divided by 12. So once you observe here, in place of n, what you got? K plus 1, k plus 1 plus 1 whole square, k plus 1 plus 2 divided by 12. So clearly we can say that the given statement is true for n is equals to k plus 1 and write the case for. What is that? By principle of mathematical induction, S of n is true for all positive integers or n belongs to n. Okay. So next question number 6. 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on up to n terms. So here also you can find the nth term of the given series. So once you observe the numerator, so what are the numerator? Just write first numerator values 1 cube plus 1 cube plus 2 cube plus 1 cube plus 2 cube plus 3 cube. So this is what sum of the cubes of the terms. We know that sum of the cubes of the terms formula is n square into n plus 1 whole square by 4. That is the numerator. And what is the denominator? First denominator 1, second denominator 1 plus 3, next 1 plus 3 plus 5. Clearly 1, 3, 5, that are the odd terms. We know that sum of the odd terms formula is n square. Clearly n square cancelled, which is equals to what? N by 24 plus 2n square plus 9n plus 13. Now let S of n is the given statement. What is that? 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on. So what you got here? N plus 1 whole square by 4, which is equals to n by 24, 2n square plus 9n plus 13. Clearly, which is LHS and which is RHS. And what is the case 1? You prove for n is equals to 1. You can consider LHS and RHS separately. So here LHS. Here n is equal to 1 means only first term. What is the first term? 1 cube by 1. Clearly again, which is 1. So next RHS. What is RHS? This one. So write n by 24 into 2n square plus 9n plus 13. Now we can replace n by what? 1. That is 1 by 24, 2n square. 2 into 1 square, 2 plus 9 into 1, 9 plus 13. So here 2 plus 9, 11. 11 plus 13, 24. Clearly 24, 24 cancel. This is also 1. So LHS 1 and RHS 1, we can say that the given statement is true for n is equals to 1. So next case 2, assume that n is equals to k. So which means just replace n by k in equation 1, both LHS as well as RHS. So that is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on. So here replace n by what? K. That is k plus 1 whole square by 4, which is equal to, on right hand side also replace n by k. That is k by 24, 2k square plus 9k plus 13. So this is equation 2. And what is case 3? You prove for n is equals to k plus 1. So we can consider LHS, and from the LHS we can prove RHS. So clearly what is LHS of equation 1? This one. In the place of n, we can substitute k plus 1. So that is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on. Replace n by what? K plus 1. K plus 1 plus 1 whole square divided by what? 4. And what is the next step? The next step is RHS of case 2 plus last term. So clearly what is the RHS of case 2? This one. So write as it is k by 24 into 2k square plus 9k plus 13. Plus what is the last term? This one. K plus 1 plus 1, 2. K plus 2 whole square by 4. So clearly what is the LCM here? 24 for LCM is 24. And numerator value k into 2k square, that is 2k cube, k into 9k plus 9k square plus k into 13, 13k. But here LCM is 24, here we have 4, that is 4 6 24. Means multiply 6 with k plus 2 whole square. 6 into k plus 2 whole square, which is 2k cube plus 9k square plus 13k plus 6 into k plus 2 whole square, that is in the form of a plus b whole square. A square, that is k square plus b square, that is 2 square 4 plus 2ab, that is 2k into 2, 4k. So which is divided by what? 24. Again simplifying this, 2k cube plus 9k square plus 13k, 6 into k square, 6k square, 6 into 4, 24, again 6 into 4, 24k divided by 24. Again which is, write the like terms, 2k cube, 9k square plus 6k square, 15k square, next 13k plus 24k, that is 37k plus 24 by 24. So this is LHS part. And consider RHS. So what is RHS of equation 1? N by 24 into 2n square plus 9n plus 13. Here replace n by what? K plus 1. So here write in place of n just k plus 1. That is k plus 1 by 24 into 2 times of k plus 1 whole square plus 9 times of k plus 1 plus 13. So simplifying bracket value, that is k plus 1 by 24 2 into a plus b whole square formula, a square that is k square plus b square that is 1 plus 2 into k into 1 that is 2k, multiplying 9 inside of the bracket, 9 into k, 9k plus 9 into 1, 9 plus 13. Again which is k plus 1 by 24 multiplying with 2. 2k square plus 2 into 2, 4k plus 9k, 9 plus 13, 22. Again which is k plus 1 by 24, 2k square, 4k plus 9k, 13k, 2 plus 22, 24. Next again multiplying with k and multiplying with 1. First k into this one, 2k into 2k square, 2k cube, k into 13k, 13k square, k into 24, 24k. Next multiplying with 1, 1 into this one, again we'll get same. That is 2k square plus 13k plus 24. Divided by what? 24. So here we can simplify this and write the like terms first. 2k cube, 13 plus 2, 15k square plus 24 plus 13, 37k plus 24 divided by what? 24. Clearly once you observe these two, this is LHS part and this is RHS part. So both LHS and RHS are equal. We can say that the given statement is true for n is equals to k plus 1 and write case 4. So what is case 4? By principle of mathematical induction, the given statement is true for n belongs to n. Okay. ఈ వీడియోలో మీకు ఏమైనా డౌట్స్ ఉంటే ప్లీజ్ కామెంట్ చేయండి. ఈ వీడియో నచ్చినట్లయితే లైక్ అండ్ షేర్ చేయండి. ఇంకా మన ఛానల్ని ఎవరైనా సబ్స్క్రైబ్ చేసుకునే వాళ్ళు ఉంటే సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ.